Hey everyone, we're going to finish up section 7.8 with this set of notes. This is type 2 improper integrals. Okay? These are integrals that have asymptotes in the middle of the integral. So let's take a look at this. If I wanted to evaluate this from 2 to 5, what's wrong? There's an asymptote at 2. Okay? So because of that, we have to do this problem slightly differently. If you have an asymptote either at A or at B, we're going to take that out and put a limit in there. So we can't go to B in this problem, so we're going to go to B from the left side. Or in this problem, we can't go to A, so we're going to go from A to the right side. This is what we're going to use for the problem we just did. The 2 was an asymptote, so we have to do 2 plus. What if it's an asymptote in the middle? Like what if there's an asymptote at some point in the middle? We go from A to the asymptote, and then from asymptote to B. So we just split it into 2 problems. Let's go back and try this one. This one has an asymptote at 2. So, I'm going to say it's the limit as t goes to 2 from the right side, because the right side is the side in between here. The integral of t to 5, and this is x minus 2 to the negative 1/2. Let's integrate. The limit as t approaches 2 from the right side of, that's going to be 2 square root of x minus 2 evaluated from t to 5. Well, this is 2 times the square root of 5 minus 2 minus 2 times the square root of, if I plug in t here and then plug in the 2 to t, I get 2 minus 2. This is 2 square root of 3 minus, this is 2 square root of 0. Is square root of 0 still an asymptote? No, square root of 0 is 0. This one is fine. This one converges 2 square roots of 3. So this problem, even though there's an asymptote at one of the endpoints, I can still find it because it converges. Let's take a look at this one. This is type 2 because there's an asymptote at x equals 1. It's in the middle of 0 to 3. So I've got to split it into 2 problems. I got to go at 1 from the left side, and I got to go 1 from the right side. Now let's integrate. This is limit as t goes to 1 left side of the integral of 1 over something is natural log absolute value of that something, plus same thing over here. Now it's just a matter of plugging some things in. This is 0 to t. So let's plug in t. So this is natural log of the absolute value. If I plug in t, I would have t minus 1. And t is 1, I have 1 minus 1. Let's stop there for a second. This is natural log of 0. The natural log of 0, think about it. Think about what natural log looks like. What is the natural log of 0? It doesn't exist. It goes down to negative infinity. So because we know that this goes to negative infinity, I don't need to finish the problem. Automatically, this one diverges. Once you get an infinity or a negative infinity in the problem, you're done. It diverges. This one didn't work because natural log of 0 doesn't exist. It's negative infinity. This one worked because square root of 0 does exist, so it's okay. That's type 2 improper integrals. Improper integrals are in some way, shape, or form associated with infinity. If you have any questions, come talk to me. Thanks.